And I guess there couldn't have been a better marketing for this talk than Mark Callahan saying that he had done some of his tests using this software. So I will be presenting, and David is here at the conference as well. The paper on the software that we use to run and analyze MongoDB performance tests at MongoDB. And I should also say, yes, so the software, we call it Distributed Systems Infrastructure, or DSI, as you heard Mark mentioning it. And as part of writing this article, we have finally also open sourced this, so it's available on GitHub. The link is in the paper. And oh, let me reload this. So to give some context what this software does, one way to do it is to actually explain how this paper relates to some other blog posts and articles that we have published in recent years. So to the left, there is a link to a blog post about the continuous integration system that we use in MongoDB. It's called Evergreen. For the purpose of this presentation, it's just a continuous integration system. But yeah, the point is that we wanted to do performance testing on a daily basis, which not everybody in the industry, I think, are necessarily doing, or at least weren't doing in 2016. To the right, there are two other articles that were projects done by me and David and some colleagues. So the first one is a series of articles about how we evaluated whether we can use a public cloud for performance testing. Can we get repeatable results? What tuning we need to do? And the relevance for this presentation is that the DSI software essentially applies this configuration that we found in this project. So this way, when we use it in CI, or when some MongoDB engineer uses DSI, or like Mark had done for his presentation, the servers will automatically be configured based on the findings from that work. And the final link then is an article on how we analyze the performance results. There is a picture at the end of this presentation then where we can see how we find change points in our performance result history. And yes, and our presentation today then is about the software that binds all of this together, called DSI. So DSI is the executable that Evergreen, for example, will launch, and then does all of the complicated distributed systems stuff for performance testing. So I joined David's team in 2016, and at that point, something like DSI was already running in production, doing daily performance tests. But it was maybe more like through some accidental evolution that this system had come to birth. So it was a collection of Bash scripts, Terraform, Python scripts, and also Go put together, and it was kind of working. But we started a project to do a more coherent and well-designed system, which now became DSI. So because we had been using this accidentally evolved system, we kind of had a list of requirements that we understood that we want the system to do. So one was, and this is a non-trivial requirement, to end-to-end automation. Obviously, if you run something in CI, this has to be the case. And at least back then, if I compare to other databases, I know many database vendors do not actually run this kind of system level realistic tests fully automated. Interestingly, people participating in this conference are the ones who seem to be most advanced. So, so that was mentioned in the related work. We wanted the same system to be used both in CI and people using it for manual benchmarking. Of course, one reason for this is that if we find a regression in CI, then somebody has to manually be able to run the same test and analyze it. But we also use the same software for so-called explorative benchmarking, which is in a way not fully automated, so it's something you do as you go and see, kind of explore what you might find from MongoDB. We wanted to use elastic cloud infrastructure, so we I think today most of the build finishes in 1 hour, but some tests, of course, intentionally run longer, like 5 hours or so. So this is important for developer productivity, so that if a developer wants to test while they are finalizing a pull request, they don't need to wait many hours. And to do this, of course, we have to parallelize all testing, and this is then only possible doing in public cloud. And the previous the blog post I mentioned on the previous slide was like a huge validation or a huge milestone to say that yes, we can trust public cloud to produce repeatable results. We wanted to have a system where everything is driven by configuration, which was not the case with the bash scripts where we started from. So that if we wanted to add a slightly different test or a slightly different MongoDB configuration, we would not have to change a single line of Python code, and bash code there is no more in this system. So everything should be configurable, and also we wanted to use everything to be in a single YAML-based system, so that it's a consistent user experience. So this software uses many components. So Terraform configuration files are kind of like JSON. MongoDB configuration file is YAML-based. Linkbench and YCSB have Java properties files, and so on and so on. So if as a user you have to go through all of these files with different syntax, and you don't even know what the file names are, it's a lot of overhead to just run a single test with all these components. Then we also needed modularity, so you can easily change a different EC2 instance type with a different type of MongoDB cluster, but still run the same test. So you can mix and match different configurations. And we needed to have capture data during the test so that we can diagnose what happened. Of course, at the end of the test, the EC2 instances are destroyed. So by the time a human looks at the regression, all of those files are gone. We needed to store them somewhere. And I mentioned in the beginning, repeatability was important. And in fact, the way we designed the configuration files supports repeatability as well. So on a very high level, this is what a continuous integration system does. You have a Git repository with source code, and when somebody adds a commit to it, or in our case, because these tests are fairly expensive, we schedule it to run once a day, and this is what Evergreen does. And then Evergreen checks out the source code, and there is typically like a single server in EC2, and then Evergreen or other CI system as an agent when it runs the test. And from the CI point of view, this is what is happening. So it's running, let's say, a test called DSI, and then it executes for a while, and at the end there are some test results. And so this is what Evergreen thinks is happening. So what DSI then actually does is this. So the on the left side, you have the different modules or different phases that DSI does, and each of these is a top-level executable. So you would execute Python executables with these names. When you think about it, it's quite self-evident. So you provision your infrastructure. Workload setup is dependencies for the workload. So in system setup, you would maybe provision, like format the disk. In workload setup, if I'm running Linkbench, then I need to install Java, for example. MongoDB setup, of course, deploys the cluster, and then test control runs the actual test. But this is an orchestrator, so DSI itself is not a benchmark. DSI supports Linkbench, YCSB, PyTPCC, bench run, which is MongoDB's own testing tool. Jenny is the newer testing tool, and we even support sysbench. I think that's all that we added support for. And then at the end there is some analysis, but over time we realized that actually we have extracted this regression analysis separately, because it's done with the delay. So it's time series analysis, and if today there is a regression, it might take 4 or 5 days for the algorithm to decide that, hey, 5 days ago, or like 5 builds ago, there was a regression. But there is still some static analysis part of DSI. For example, if MongoDB crashed and there is a core file, or if there are some errors in the log file. And then at the end, of course, importantly, we must tear down all the EC2 infrastructure, because otherwise it quickly becomes expensive, and that has happened a few times. I want to also emphasize that the benchmark itself, so in this example, YCSB, is also running on an EC2 instance. Of course, we want it to be close to the MongoDB cluster, and it might be a fairly large instance as well. DSI, if you would run it manually, DSI typically is what is running on my laptop. So DSI orchestrates the benchmarking, which happens then in the cloud. So let's look at a few configuration files. So each of these modules has one configuration file, and the configuration files have fixed names. So the model is that we create an empty directory, and then for each of these phases, such as here MongoDB setup, there is a configuration file. So in the DSI repository, we of course have many variants of this, but to run the actual test, we choose one of them, or you can create your own, and you call it MongoDB setup.yaml. And for each of the other phase, it's also the name of the executable.yaml. And this goes back to one of the requirements where we wanted the user, like we wanted there to be a easy to remember set of names that are always the same. And we also chose a system where there are no command line options in DSI. So everything has to be in the configuration file. One reason is because there is so much that you need to configure. So before we did this, sometimes like to do one thing, you might have 3 lines of options for a single command. And the other is that this enforces repeatability. So at the end of each test, we save the configuration files. And if you want to reproduce a test, you can download this in a tar file. And when you unpack it into a directory, you can go into this directory and just run DSI again, and it will use the exact same configuration. So you don't need to go and look in the log file what command line options were used, because there are no command line options. Everything is in this file. So a few examples here. MongoDB setup is one of the most interesting ones. So it can describe one or more clusters. Here it's a MongoDB replica set. And in Amazon, of course, we don't know the IP addresses ahead of time, or the public ones at least. So we have this kind of variable or reference syntax with the $sign. You can reference other parts of the configuration. And that's also used here later. So let me first talk about here at the top. Here we embed the MongoDB config file. So like I said, we wanted to get away from the user having to know where is the MongoDB configuration file, where is the YCSB configuration file. So they are all here. There is just this set of YAML files for DSI, which embeds all the other configuration. And of course, DSI then extracts this and creates a file which is used by MongoDB. At the bottom, there is some information about the MongoDB cluster that we configure here. And this is used by the next phase, which is test control, which I will show soon. And the point of this is that although there is a set of separate files for reasons of modularity, actually it's all a combined configuration. So here, for example, to the MongoDB, I need to use SSH, but there is no SSH configuration here, because that happens to be in the first file called infrastructure provisioning.yaml. And so we don't duplicate the configuration, rather at any part of DSI can you access all of the configuration. And this, of course, is to avoid errors, so that you don't have, like, if you want to use the same IP address, for example, you access it from the same place. So otherwise you might accidentally have the different configuration in another file. So here, if you look at line 20, MongoDB URL is just something we store here, because when we go to the test control file, we can use it here in a file. Here again, we embed a YCSB configuration file. And one of the configurations is where is the MongoDB cluster. At the top here is the actual benchmark, YCSB, and this is just a command line. And here you can see we designed DSI so that you can essentially execute anything you want. You could even write your own executable if you want to test a workload that you wrote yourself. The type on line 3 is not very important, but in this case, for these standard benchmarks that we support, when I use YCSB here as the type, then earlier the workload setup knows which dependencies need to be installed. But you could, of course, just provide your own workload setup file if you don't want to do that. And the only other integration point when you add support for a new benchmark is how to parse the results. So typically all tools output different results in different file formats, and we have to write a bit of Python then to parse that, and so that DSI can report it back to the CI. And yes, there you see the MongoDB URL that I spoke about. So that was what the system architecture looked like. And this is now a screenshot of Evergreen. So DSI itself is command line based, but I just wanted to show, once you have run a test, in this case we have run YCSB, what the results look like when we then search for regression in the CI environment. So in Evergreen, of course, this is like a specific GitHub commit that had some Jira ticket code and who is the author of this commit and when the test run. So this is metadata. On the top right corner, if this was now a unit test or other correctness test, this would be the main area of interest, which is the box green or red. So in the case of DSI, this is kind of a byproduct. So we don't, like I said, during the test run, we don't yet decide whether the performance result is a regression or not. This is done later, and it's done as change point detection over the whole time series. But here we do these static checks, such as checking whether there are core files or not, or even like a simple thing: did the benchmark client exit with a success code, or did the benchmark itself crash? Here are some files. The first one is the what I mentioned, that we have DSI runs in a work directory. So here we have stored all the configuration, but also all the log files and everything that we save from the MongoDB cluster, and of course the YCSB log files as well. So here you can find everything you need to analyze what happened during this test run, or even to repeat the test run by running DSI manually. And then, of course, most interestingly is the graph. So this is each point on this kind of graph is a daily build. And you can see there on December 12, there has been a significant regression. And the dark blue lines, I think you can...
Henrik,
yes.
I'm sorry, we are out of time slightly.
Okay,
so
that's okay.
You can conclude briefly.
Yes. In fact, I can end at this slide, and I'm sorry I was going to leave a few minutes for questions, but this is a good moment to stop.
No worries.